I would like to integrate dx over cosine to the power 4x. Now this might seem very easy because this just involves one term, but believe me, it is a combination of a very great technique which I still admire, as well as a bit of use substitution, because it'll be used later on. So you might try some things here, writing this as the integral of secant to the power 4x dx and then solving. That can be done, but I just found a great technique which can help us solve this very easily. So just carefully watch this. This is nothing but the integral of 1 times dx over cosine to the power 4x, right? Someone just call me. Okay, that's okay. Yeah, so so it's nothing but the integral of 1 times dx over cosine to the power 4x. Now just this is really amazing. I still find it amazing. 1 is nothing but actually let me write it here. Sine squared of x plus the cosine squared of x is 1, right? So if you see somewhere sine squared plus cosine squared, you just substitute it as 1, right? But I can do the other way around, right? If I see a 1, I can substitute that as sine squared plus cosine squared. So this is really amazing. So let's just substitute that 1 that we have there as sine squared of x plus cosine squared of x, and in the denominator we're still left with that cosine to the power 4x dx. And now this is the integral of, if you split it up, then it is the integral of sine squared of x over cosine to the power 4x plus cosine squared over cosine 4 is nothing but 1 over cosine squared of x dx. Then this becomes the integral of I can write this as sine squared of x over cosine squared of x times 1 over cosine squared of x, right? If you split the denominator, it just turns out to be cosine to the power 4x. Oops, what did I do? Okay, let's just zoom out. Okay, I'm sorry about that. Yeah, so this is the cosine squared of x. So this is the I just split the cosine to the power 4x into cosine squared and cosine squared. So this becomes plus 1 over cosine squared is the secant squared. 1 over cosine squared is the secant squared of x, and we have a dx, of course. So this is the integral of sine squared over cosine squared is tangent squared. 1 over cosine squared is secant squared plus a secant squared of x dx. Well, actually you could have done the thing that I said before. You can write this as 1 over secant to the 4th and just split it up like this. Actually, this is not such a great technique, but yeah, it is quite interesting to watch. Okay, so now let's just substitute for the first integral. I'll just split the integral up. So this is tangent squared of x times the secant squared of x plus the integral of secant squared of x, and I'll forget about the dx just for now. So for the first integral, let's substitute tangent of x as u. So you get that this is the integral of u squared times secant squared of x dx, and now I'll write dx. So secant squared of x dx is du, right? I won't do it every time, so I hope you know this. And this, the integral of secant squared is pretty obvious. It is the tangent of x, and this becomes u cubed over 3, but u is tangent of x, so it's tangent of x cubed over 3 plus the tangent of x plus some constant. So yeah, this was quite an interesting problem. I found this substitution as very useful because I didn't find too much of the use of this identity somewhere close to an integral. right? You could not imagine that you could use this identity in an integral to further simplify the problem. So yeah, you could also have done this problem like you could have written this as the integral of secant to the power 4x dx. Then you could have split it up into secant squared and secant squared. Then you could have substituted one secant squared as 1 plus tangent squared, and you would have gotten the same thing. So, but that's kind of boring, But this gets us the same place, right? So this was kind of nice. So yeah, I'll do one more video on the miscellaneous problems, and I'll see you in the next video.